All right, let's get started. I'm John. I'm a software engineer at Yodel, and I'm going to talk to you about web scraping. It's not really BS. Beautiful soup. It got you to come here, though. I'm sorry. So this is Hacker News. You guys can have probably all spent some time on this site here and wasted a lot of time here. There's 1,500 articles at any given time, and that's a lot of reading. I don't get any coding done when I end up here, so I thought I'd try to find a solution. So if you guys have used Chrome, maybe you've right-clicked and you've seen the Inspect Element option, and when you use that, you can end up on a screen like this that actually shows you what the DOM looks like. So HTML is a basic tree structure that you're going to try to you want to parse and pull information out of and try to get some other structure. This tree might be really ugly. It might be filled with nested tables and it might be horrible to look at. But you can always get some structure out of it, except if the tree is bad, if somebody forgot to close a tag or has poorly formatted HTML for any reason. So Hacker News is well formatted, which is nice. It's built with tables, which is sort of weird in 2014 to see tables nested like this. But there's a couple of pieces here on each article. So you see the articles here. There's a little bit of buffer in between each one of them, and the actual link to the article that you might want to see. And then down below, there's points and how many comments are here. So I could scrape this and gather some news that gather all the news there is to read, but that's not going to be really helpful for me. So what I'm going to try to do is filter some of this and find the things that are interesting. And to be a little silly, I'm going to save them into Pocket. This is a bookmarking service, so I can waste my time later. So this is I'm going to go through the scraper that I made. It's pretty simple. I know this is a novice talk, so if you guys have any questions about what this scraper does, feel free to interrupt me and ask questions. So I'm using two libraries, Requests and Beautiful Soup. Requests is a library for HTTP processing, for doing gets and posts. And I'm not going to talk a lot about it because it's really easy. You're going to use the get method and you're going to use the post method to do things, and you're going to give it some URL. Beautiful Soup is a little more interesting because it's a parser for HTML. An interesting thing about Beautiful Soup that other parsers don't have is that it often can deal well with poorly structured data because you can plug in different parsers and have better luck with a particular parser for some particular poorly formed HTML. So the first thing I need to do is get the front page of Hacker News. So I have a function, getFrontPage. It uses requests, and it gets this URL. And it returns a response object. I can check to see that the response was good, that it worked. There's a lot of error handling that I left out of here to make the slide a little more visible. And then I create a Beautiful Soup object with that text. So the frontpage.text, this returns the actual HTML that the request returned, and now I have that whole front page that I can start to deal with. Something to note here is if there's any JavaScript that might have acted on that page, you don't get that. You just get that initial page load. If you are scraping a page that has some JavaScript, you may need to use some other tools like Selenium. So creating the Beautiful Soup object is just a very simple constructor, and then I return that. So now I want to use this object and find things that are interesting. So I took a look at the structure of the page, and you can see here I have some search attributes up at the top, and these are this is what I'm going to use to find the interesting elements. Now, I'd like to say that you could write some automatic web crawler that does a lot of this for you, but each page is so different, and there's so much variation and a whole lot of bad HTML. There's no real way to make a general solution to it. So this is something you're always going to go through. You're going to look at the page, you're going to inspect it, and try to get a loose understanding of what that structure is, and then try to make something out of it. So I have one argument here, soup, and this is the beautiful soup object that I created before. And I use a find all function, which can anybody guess what that does? The beautiful soup has a pretty good API. It's very intuitive. So I'm looking for the table data elements that have these attributes, and I'm going to iterate through them. And from that, I'm going to filter out things that are interesting. So because it's a tree, it has a notion of siblings. Everybody knows what a tree is. So anything on the same level is a sibling, and beautiful soup can tell me what its siblings are. In this case, because I know that each structure is made up of three things: this root object that I found and its two siblings. I use the limit parameter, and I just say I want the 2. This is just like a SQL limit statement. And here I want the post ID. This is something I'm going to use to look things up. And the siblings are it's just a list. It's a Python list. We've all dealt with those. And the inside is what's known as a tag object, and this is the most fundamental beautiful soup object. And it gives you the different. It's a Python object that describes what this HTML tag has. It has attributes. It has some position in the tree. In this case, I'm using A, and this A here, this actually represents the anchor tag. So there's a little bit of magic under the hood that when the tag object is created, it will let you access children object based on the name of that tag. So that's kind of cool. And HTML has attributes, IDs, things like that. So I want to look for the anchor tag that has this post ID, and here I'm gonna pick that out. There's a little bit of extra text around it, but it's always the same extra text. So I start looking at the 4th character, and I get this little key that I'm going to use. Yes. Okay, so I found this root object, the initial one that I found on the what's really the second line here in items, and I look at the siblings. If we go back to this, can I go back to an earlier slide? Here. Let's see, do you see the, right under center, there's this ID equals up, and then this string. I'm going to look for that. Not in that particular spot, but this is all around, and I'm going to use this for the key. So what I'm doing here is I'm taking this first sibling of this TD item, and I'm looking at the anchor tag, and then I'm looking at its attributes. And I actually think I have an error in this slide because a TD isn't an HTML attribute. Thank you for calling that. That's in my actual code that works that I'll show you guys in a little bit. It will have the correct attribute that I was looking for here. But I think it was just the ID that I was looking at there. Yes. And with the link, it's the same thing. I'm looking at the href, and that gives me the actual link. So I have two other functions I wrote that I just wrote them because they cluttered up this slide. It's actually enough code that I could have done these inline. But I want to get the score and I want to get the number of comments so I can filter them. And I'm interested in things that have Python in the title, or they have a score of greater than 50 and 10 comments. So people are voting them and talking about them. And then I turn this structure that I sort of deconstructed here, and I put it into a dictionary, and I return a list of dictionaries that has the information that I need. So these are my functions to get the score and get the comments. And again, you see this is just find. So before I used find all, and that returned a list of things. Find just returns one thing. You'll see this a lot in this library. I'm looking for spans that have an ID that's this score plus the post ID. And that inside that span is the score, and this is just a little bit of Python to split it up. So I'm taking the text. It's space delimited, so I split it, and I take the first one. If we come back here, you can see 7 points. So I'm just getting that first element. And I'm doing a similar thing with comments. So here's the useless part where I add it to my bookmarking service to read it later. I had to go through a little bit of a little song and dance to get my application authorized. There was some OAuth stuff I had to deal with. I actually used requests to get the consumer key, and then had to construct a URL, put it in my browser, and actually click through to say, yes, this is how I want to use it, because they kind of expect you to be building web applications, not console applications. But so Pocket has a REST API that I can use with HTTP requests, and it takes some parameters, a URL and a couple of tokens. And so this is the add function, and the URL that it takes is the URL that I wanna save for later, and I post it. It takes some data and a target, and that's all there is to requests. So this is my main function here. I get the front page. I use a partial function. This just makes the code look a little bit neater. And I find my interesting links, and then I post them to Pocket. Now, I know the internet's been a little weird. Let's see. Okay, so this is my Pocket right now, and I am going to run the scraper. Find some things. And now I have new things? Yes, yes I do. So I can waste time later now. Okay, are there any questions so far?
Can you repeat why you're using partial here?
So I'm using partial strictly to clean up this print statement, so it's not so long. So a partial function is so the add Pocket function takes a couple of parameters, and I'm always going to be using the same ones, the consumer keys here. So what I'm doing is I'm making another function that has these two sort of baked into it, so that I can then go on to call it later. It's from functional programming. It doesn't really add any benefit to the code other than to make it a little more readable, I think. You may think differently and prefer to do it another way. So, any other questions? Well, if we So if I can get my mouse over there, I see 3, 6, 9. So this, I had bookmarked this during your talk. So I got 9. And on Hacker News, there are 30. So I'm just using the first page here. But there's no reason why you couldn't use more pages. When you're using Beautiful Soup, you have the HTML in a variable on your machine. It's actually on your disk. So you've taken care of the authentication problem already. Requests has authentication an authentication mechanism that you can use. It sort of it keeps the session alive. I don't remember the API offhand, but I tried it out once and it was pretty smooth. I copied it from the documentation, and it worked. So if there is authentication in some sort of session that you need to keep open, this request has that capability.
Which is the part like you keep running again and again because there can be updates, but you don't want to grabbing the same content twice, 3 times every time.
Right. So that's an interesting problem that I had not solved for this silly demonstration. But the Pocket API lets me take a look at what I have saved already, so I can look and see if there are duplicates. Because sometimes a duplicate post will be added by somebody else on Hacker News, but it'll be the same URL. There'll be a different set of comments on it. So I really want to check by using the part of the Pocket API that tells me what I already have in there, whether I'm duplicating it. Yeah. Right. Right. So these are all the search functions. You do something with one thing or you do something with a list, and that's the pattern that you're going to use. So you find or you find all, or you do with parents or siblings or previous siblings, next and previous. So it's all just moving around that tree. And each one of these search functions is going to take some sort of a filter. So I might take B to look for all the bold tags. I can use regular expressions, lists if I want to be able to find multiple things. Lists don't really make sense if you're looking for one thing, but they're part of the find all group of functions. You can take functions if none of this suits your fancy, and you can write a function that describes the element that you want. If this returns true, it matches. Otherwise, it doesn't. So this is good for filtering out things that have attributes in sort of a nice way. So I can look for things that have classes but not IDs. So these are the actual. This is the actual API. This is the whole thing. It takes names, some attributes, whether it should be recursive, some text, and the limit that we saw earlier. So the name is just that matcher. Attributes is a dictionary that has attributes to match on. Recursive just says, do you keep searching through grandchildren and keep going down the tree until you can't find anything more, or do you stop at the children of this node? Text lets you search for text. This is useful because we've dealt mostly with tags, but sometimes you want to know that this string is on the page, and this is a way that you can search for it. Limit just limits the number of items that are returned. This is useful if you know the structure or there's some gargantuan page and you don't want to deal with the whole thing. You just want to get a sample from it. And there's some keyword arguments that you can use to search for things with a particular attribute. So I can just say, I want things that have this ID. We saw before that you can reference child elements to actually navigate once you have something. If you want to get that next element, you can, if you have the the root of the HTML document. You can say I want the header, I want the body, or the title, and the object that you get back will automatically have generated this for you. So what about a bigger challenge, Wikipedia? All the pages on Wikipedia are different. So I don't know if I have time to get through all of this. But I want to, you guys have seen in the newspaper like 50 years ago today, they'll give you some facts. Wikipedia has a page like that will show you what happened 50 years ago. Can somebody take a, somebody who has a laptop, open up the page to August, what, 1964? Oh, it was actually pretty easy. This is the whole scraper. This is a little command line tool that finds out what today is and gets me the name of the month and constructs this URL for 50 years ago. And I actually go to this Wikipedia page with requests and I get its text. I turn it into a beautiful soup object and I look for all the when you see this page, it has the dates broken out. So I want to find the each one of these blocks. They're not really in a table structure, so I have to imagine what some structure on top of this is. And then I find all the things that are associated with today. And let's see what happened today. Was that? So this is just a silly little tool that you could use when you start your terminal, or you could use this as a inside of a web app to pull some data from whatever source. And the process is simple. The difficult part is figuring out the structure of that page that you found that you want to get the data out of. But once you've figured out that structure, the code is easy. And here's some links to the documentation for requests, Beautiful Soup. LXML is one of the parsers that Beautiful Soup looks for. A lot of people just use that if it suits their needs. So you can take a look at the documentation for that. There's another article on web scraping, the whole process that I found on Hacker News. The code for my scraper is there, and there's my email if you have any questions for me. But we have a couple of minutes left, so are there any more questions? My presentation is already posted on SpeakerDeck, and I will be tweeting it in about 5 minutes. So Scrapey is a utility for making web crawlers, and that's for finding a page and then going to all the children's links and scraping those pages. I use Beautiful Soup because it's the tool I know, and it uses LXML or whatever other parser I want to use. So it provides a level of abstraction and a consistent API that I like. It's a matter of personal preference and what you're comfortable with. So try them out and see what works for you.
Yeah. Can you mention some comparable things to the Beautiful Soup?
Nothing compares to Beautiful Soup. I've heard people talk about.
Like it does select the LXML.
But again, you're using LXML, which is one of the parsers that Beautiful Soup uses. So there. Oh, to use CSS selectors to walk through the DOM, yeah. So CSS selectors, XPath are another thing you can use to search the DOM. CSS selectors?
Like CSS select all one big word.
CSS select.
Do they have, like, sometimes people change their page, right?
Yeah, that's a risk when you're scraping. Another risk is that if you are accessing a page that has data that they want to keep private, or they don't want to show to robots. They want to show to people because there's advertisements on it. You need to pay attention to rate limiting and not looking like a bot. So maybe getting some proxies that have different URLs. So we're out of time. If you have any more questions, speak to me after or send me an email, and I will tweet my slides in just a moment. Thanks, guys.